So another time, like I said before, you might come across a question where you think, oh, I don't know how to solve this because nobody showed me how to do this kind of question. Well, this is a question we can in fact solve, but we need a trig identity probably to help us along. So one way we could rewrite this is it might look more familiar to you as 2 sine x cos x minus 1. And this I can figure out, there is an identity here. This is straight off of what the sheet uses. So I could replace this as 2 times the sine of 2x equals, minus 1 equals 0. So of course I could rearrange some stuff here. 2 sine 2x equals 1. So I'm looking for where sine 2x would be equal to 1/2. Okay. So I don't want to... Question?
Is that it?
That's, well, we haven't solved the full thing. I don't want to spend today's class practicing more trig solving. I want us to stay in the frame of mind of how we use identities. But this is how we could set it up to save it like to solve it like we did a couple of days ago. Okay. So anyway, if you do have questions about solving, I can stick around a bit if you want to go over those. But today we're going to stick to identities for the lesson anyway. Okay. So the next one, to simplify 2x over sine 2x. Again, this is the one you like to see because there's only one identity that you can switch it for. If I tidy up my fraction, I get 1 over cos x, which is the secant of x. So these kind of short simplification questions, they're the kind of ones that quite often, you might have already seen them in your homework, in fact, pop up as a multiple choice. It would say something like, you know, your choices would be like A, cos x, B, sine x, C, secant x, and you know, stuff like that. But you should be, you know, comfortable doing it like that. Sometimes you may not have the answer right in front of you. You might have to pick from the multiple choices to figure out which one is the proof. Okay, the last one that we'll try. Here's a proof from a previous provincial exam. See if you can figure out how this worked to get the left side to look like the right side. Okay, so I'm going to try to catch up to you. I know most of you are either there or shortly will be there. So the real trick here was to factor the bottom so that you took the 2 out. The 2 was on both pieces of the bottom, so this step is pretty much the crucial one. If you got there, chances are you sailed through it. What are some hints that you want to get rid of a 2? Well, there's a 2 in this identity, which we know that's the only thing I can replace it with. So if I've got a 2 on the top and there's no 2 over here, that means I got to get rid of it somehow. So how could I do that? I need to factor it out on the bottom. So that might be one way you think of how I got to approach this to get a factored 2 out. So if I cancel those out, I get sine theta cos theta over 1 minus cos squared theta. And hopefully you're comfortable this is now going to be replaced with sine squared. And since I'm running out of space here, I'll tidy it up. I'll go cos theta over sine theta, which is the cotangent of theta. And I'm going to do this one Latin style. Okay. Well, you guys missed it. You were away on a PE trip. But anyways, this would be your left-hand side equals right-hand side. LHS equals RHS. Okay? So that concludes for now, unless there's any questions.